interference will be equal to T equal to m lambda divided by 2n. Okay, so this is the cases for the development there. Okay, so this is for constructive and destructive interference under this condition. Then the next one we will do in the cases. That means the N1 is smaller than N and N2 is larger than N. In which cases it's called B. So this is a 27.5. So in these cases, case B. Case B, we like to say the N1, the refraction resulting in phase for changes at both top and bottom, and both top and bottom surface of the film. In these cases, means the index N1 is smaller than N, and N2 is larger than N. Okay, and then the next one is N1 is larger than N, and N2 is smaller than N. In these cases, phase change at both surfaces. At both surfaces. And then in this one is there's no phase change at either no phase changes at either surface. Okay, if that is the cases, then we like to have the constructive interference. Constructive interference will be equal to T is equal to m times lambda divided by 2n. Destructive interference, the T equal to m plus 1.5 divided by lambda divided by 2n. So this is two cases about the too bad. About the refraction, and in generally, in the homework, there's a lot of homework about the what we call about the constructive interference and destructive interference. Now that is Alex, you're this way.
Oh, turn off. Okay.
Not yet, until we talk about talking about diffraction. We like to say, what is diffraction? Diffraction is treating the light can bend. It's not doing straight anymore. Instead, the light is spreading out, spread away. So this is another important phenomenon doing it. And in this optics stuff, a lot of integration. So in this class, we didn't have time go through a lot of what we call the integration stuff in here, but we just mentioned this about it. So diffraction. What that means, diffraction means the light, so we have the opening bigger. This is called single slit. So we like to make it bigger, okay? So again, the light travel, okay? So here is a laser beam spread out. The waves are in here, emitting at this point. So we're looking at the opening, big. So there's a wavefront in here. All this little tiny dot, all the tiny dot in the opening become a new light source. New light source. So when it becomes a new light source, it propagating, and then it interfere with one another. The opening like this, it interfere with one another. So finally, they reach at this point. So if this opening in here is interference with every single light source, at this point, and it creating a pattern. If this is a straight line, is a slit, then we creating a slit pattern. So that in these cases, the pattern look like this. This is the intensity. The intensity is maximum at the center and gradually tapering out in here. In these cases, we got a, in mathematical term, is called sinc function. Mathematical term is talking about sinc function. In which cases, we like to say, if this is the angle, is called theta. The angle is theta. Then sine theta is have a dark fringes, dark ring is equal to m times lambda divided by a. In which case, a is the opening of this slit. That's the opening of the slit. This is called the diffraction pattern. So we like to say, what is diffraction from a light is because the light is being spread out like this. It doesn't go straight anymore. So that is that phenomenon, in which cases is called diffraction pattern. So this is what we call with the single slit. Single slit. We can do this lab very nicely, but I don't know which schedule for doing this diffraction pattern. If you don't, then you can using this to do the special project. Now, if this slit instead of rectangular slit and become a circular slit, they have a different math involving in it, completely different math. In that cases, so you have an opening in here, and then here is the pattern. Suppose here the above is a rectangular pattern. So we like to say this pattern, this opening in here is a circular pattern. Is a circular pattern. In this particular circular pattern, if this is diameter is A, diameter is D, so the diameter opening is D. Then again, the light travel have a diffraction and then form a pattern. this pattern is going to be circular pattern. This pattern is circular pattern. The top is going to be a rectangular pattern. So this pattern is related to this angle here. This is circular pattern. This circular pattern theta the dark, the sine theta the dark is equal to 1.22 lambda divided by d. And this pattern is have a name. It's called area disk. Area disk. Area disk. So this is another very, very good experiment. We will do the next experiment, in which case is 27. I think I schedule for this experiment. What we've done in here, we have a slit or a circular one. Now, if we have a multiple slit, in which cases we call diffraction grating. I think we will do this experiment for sure. The diffraction grating we're using in a lot of your medical equipment called spectrometer, using spectrometer. This one we highly recommend you to do. So what is diffraction grating is have a lot of opening in here. In the lab, we do this grading, diffraction grading, basically about 1,000 slit in 1 inch space. So that is a very, very small spacing. With that thing, this is a multiple slit, in which cases is 1,000 slit per inch. In this cases, the thing in here related with this is a theta, and then d times sine